Alright, guys. So, an 80 kilogram student climbs a 4-meter long staircase. Guys, that makes an angle 25 degrees from the ground. Draw a picture. What's the work done by the student? What's the work done by gravity? So, here's our staircase. Angle here is 25 degrees. Students walking up the staircase.
It's Friday.
Okay. Student happily walking up the staircase. How much? What's the student's mass?
80.
T-Rex arm student. 80 kg. Okay. We know the staircase is the length of 4 meters, so that's the hypotenuse. Okay. And this is a right angle right here.
Sure.
Yep. Now we want to find the force of the work done by gravity and the work done by the student. Okay, so the situation. What forces are acting on the student? Gravity and normal. So their own force, their own legs driving them up, right? We'll call that force student and force gravity. Now, does the problem say anything about the force the student applies? No. So what's the assumption we can make?
No, we don't need the angle.
Nope. What's the assumption we can make?
Okay, it's been 2 minutes.
We got like 30 seconds left. They're opposite and equal. So the force of the students equals the force of gravity, which equals
31.36.
mg, not 9.8. G is the acceleration due to gravity. Surprising, I saw that on your last test up a lot. Force of gravity is not little g. All right. Any questions about that, guys? No. All right, now, the displacement comes in at this angle, right? So it was a free body diagram, now it's just a diagram. Okay. The displacement comes at that angle, right?
Yep.
So when you're doing these calculations, what is the angle between the force and the displacement? 90, 65, 25. So basically every possible angle, right?
115.
Okay. Well,
35, 90.
the force of the student's up, right? The displacement's this way, right? So I need this angle, which is 65.
I was right. In my head.
Good.
Was
Okay.
right.
So now if we're looking at our triangle, that's this angle up here. Right? Funny, it's fun how geometry works, right? So for part A, force equals mass times gravity. So 80 times 9.8, what is that? 784. 784. Oh, not joules. Newtons. Okay. My goodness. Okay. Work equals force times displacement times the cosine theta.
Cosine.
Right? So we have 784. Guys, thank you. Times 4
Are you recording?
times the cosine of 65. Yes, I'm recording.
Aww.
I think love you.
Hi, YouTube.
Nice job, guys.
Follow me
So-
on Twitter.
784 times 4 times cosine 65. What does that equal?
1325.
Thanks.
A little more understandable, Whitney.
It equals the number.
1325.
1325.
Yeah, 0.3.
0.3 joules. Thank you.
Man, stop talking.
All right.
You're distracting my listening.
What? Okay, thank you. Does that make sense for the work done by the student?
Yes. It sure
Okay.
does.
Now, part B, there are 3 ways to do part B. Okay? One way is by comparing the force of the student and the force of gravity. Okay? The force of the student and the force of gravity, they're equal in magnitude, but opposite in direction, right? So that means if the student and the displacement were in the same direction, that means that the gravity and the displacement are in
Different direction.
opposite directions, right? So using that reasoning, I could say they do the same work, but the work of gravity is negative. So we could just say negative 1325.3 joules because it's the same magnitude. Gravity is the same magnitude as the student's force, but opposite in direction. That would be too easy. Another way we could do this one. We could use FD cosine theta again.
That's too much work.
Okay? You don't have to do all this. There's just different ways. Okay?
Just to make sure.
Okay, so W equals FD cosine theta. I'm going to use 65 for my angle. Right? Now, if I use 65 for my angle theta, right? 4 times cosine, my force is 784, right? If I'm using 65 for my cosine, when I do cosine of 65, I'm finding this side of the triangle, right?
Yeah.
Which way does this point?
Up.
Up, right? So that means I need to make one of these
Negative.
negative. Okay? And if I do that, I get the same answer, but it is
Negative.
negative.
Okay.
Okay. Or the last way we can do this one is we can use the real angle between the force and the displacement. So gravity's here,
Sure.
right? What's the angle between gravity and the horizontal?
90.
90. Right? So what's the real angle between gravity and the displacement? 115. 25 plus 90 equals 115. Does that make sense?
Yeah.
So if I do that, so I do work equals 784 times 4 times the cosine of 115. We don't need to worry about negative signs because if you know your unit circle, cosine 115 is a negative number, right?
Yeah.
So what do I get? 784 times 4 times cosine 115. What do I get?
Negative 1325.
Did you do it in your calculator? No, why not?
Because I can do that in my head.
You do it in your head? Alright.
That's
If you do it in your calculator, you get the exact same answer.
I can do that stuff on my phone.
So all three of those ways are justifiable ways. Okay? But if you use the top one, you better have some writing to go with it. Okay? Does that make sense?
Really? You just can't say it?
No, I want you to tell me why. Okay.
Stop. Stop.
If you're not going to show your work, you gotta explain why. Yep, showing your work. Yes, Terry.
So W is work.
Yep. F is force, D is displacement. Alright? Force. So in this case, it's the force of gravity. For me, it's the force of gravity now. Right?
And F is
The thirst is real for Jade on this
the
Oh, that's not
F
a
is
camelback.
still force.
This is force of gravity.
I think it's the fall.
Okay. So here's force of gravity, here's the force of
close it
gravity.
right.
Okay? Alright. Any other questions?